Today we're going to talk about handling exceptions. So when we were dealing with files, we know that if we try to access a file that doesn't exist, the code will throw an exception. We get the red lines, the stack trace of the exception where it happened. So an exception is basically when something in the code doesn't go right, an unexpected event happens. You try to access a file and you can't find the file, or you're expecting the user to enter a number and the user doesn't enter a number, they enter a string. So that is called an exception. So an exception is actually an object. So there is a class called exception, and an exception is an object that gets generated when this unexpected event happens, when this error in the program happens and the program doesn't know what to do. So if we don't write code to handle this exception, what happens is our code crashes and it stops at the line that exception happened at. So in Java, we say that exceptions are thrown. And it is your responsibility as a programmer to make sure that you write code that detects and handles exceptions. You don't want to write code that crashes. You don't want to write code that gives the blue screen of death, like they say. So what happens if you as a programmer don't write code that handles the exception? Well, what Java does, it handles the exception for you. So it has an exception handler, and the default for Java is that it just throws back the exception at the user of the program. So the user that is running the program will get the exception thrown at them. So let's just see what this means, because this is what we've been kind of running into before. So here I have some code that I wrote. I'm just asking the user for a number, and I'm expecting them to enter the number, and maybe I'm going to print out the square of the number, math.pow of num to the power 2. Okay, so let's see what happens when we run this program and the user, by mistake, doesn't enter a number. So the user enters 10, T-E-N. An exception happens, and we get that red stack trace. So this is called a stack trace. It's tracing where the code, where the exception happened. So it started off in our code at line 24. When I tried calling nextInt on the scanner, that went into the scanner code at line 2076, which called another method, and somewhere in that method, it detected that what it's trying to read is not an int, and so it threw an exception. And when it throws an exception, it tries, every exception has a name. So here you see that the exception lives in the package java.util input mismatch exception. So this is the exception, the name of the exception. This name is important when you want to handle exceptions. And the code stopped. It never reached line 25. It never printed anything because it threw an exception. It didn't know what to do at that point, and so it exited. Another type of exception that can happen with files is if I'm trying to read in from a file, and here the code actually says you have to handle it. And so because we don't know how to handle it, we used to say throws IO exception. And this just says, I don't know what to do with it. I'm just going to throw it at whoever called me. And main, because it's the first method that gets called, it gets thrown at the user that's running this program. Right? And so here, let's just say while, let's assume the file has something in it. I'm just going to print what's in it to system.out. Read whatever is in it, one thing at a time. So here again, if I try running this code and I enter a file that doesn't exist, okay, so I just say, whatever, it throws another exception. And again, this time it's telling me that it's coming from line 33. When it tried to create the scanner tried to create some file input stream objects, and then it threw this exception. It says, I can't find this file. So we've been writing code that might, run into exceptions, but we haven't learned how to handle these exceptions. So what we want to learn today is how to handle them. And handling exceptions is not hard. The code that might throw an exception, what we do is we put it in a try block. So we wrap the code that might throw an exception in a try block, And then we put a catch and we say the exceptions that we want to catch and what we want to do if we catch that exception. Now here, when we give the exception, we have to know the exception type. So this is the class that is the object, the exception object is coming from, and we give it a variable name. And we can just, like, for example, here we're trying to open a file. Let's say the file not found exception was the one that was thrown. We can print something. So let's go and try to add some try catches into our code. So let's look here. The exception that was thrown was file not found exception. So I can come here around this code and say try doing this code. Try running this code. And I'm going to put everything inside that code. So I'm going to indent it. And I'll say I want to catch the exception, and the type of the exception is file not found exception. And we'll give it a name like EX. And we'll use that name in the future, but for now, I'll just say system.out.println could not find file plus, and then the name of the file. And so come back here and say system.out. Like, let's assume this was a program. I'll say executing. Okay. Now here, the variable name, because it's defined inside the try block, it goes out of scope when the try block goes away. So here, this is why name has a red wiggly line under it. It can't find it. So I really need to put the string name up here and initialize it in here. We might get that it's uninitialized here, so I might have to initialize it just to like the empty string or something. Okay. Well, now let's run and see what happens when we run this code with a bad file. I don't get an exception. It gracefully tells me that it could not find the file, and it goes on to execute whatever is after. So I'm not getting a program that crashes. So this is a good thing. The nice thing also about catching exceptions is that you can use it to repeat code, so that you can, keep asking the user if they entered a bad name. So here, what I can do is I can say, okay, I need to execute this code a lot. I'm going to try doing this code until I don't have an exception. Okay, so I'm going to drop it in a while. And at this point, I'm not sure what I'm going to do with a while, but I know that I want to run this code many times. Well, I want to run it at least one time, and I want to run it until, as long as I don't have any exceptions. So I can start here with having a Boolean, let's say failed. I'm going to set it to true. So I'm going to assume at the beginning that it failed because I don't have anything. And so while it failed, I'm going to keep trying. So here I'm forcing the loop to start by saying that, it failed at the beginning. And so here it failed, it's going to go in, it's going to try doing this code. If it succeeds, I want to say it's done. So after the code finishes, I can set failed to false to end the while loop. So I can just say failed here equal to false. So let's try running this code and see if we can get it to execute many times. Bad file. It says could not find the file, so it came here, it tried going to the scanner, it failed. So what happens when a line fails inside of a try, it gets thrown into the catch. So all the code that's under the try here, under the line that caused an exception, so this line caused an exception, it immediately ignores everything that's under it, and it goes immediately to the catch. So it went to the catch, and it finds that the file not found exception is there. So it matches, and it prints could not find the file. And so now it ended, and the while loop is going to come back, and it's going to check, and failed is still true, so it's asking again. And as long as I keep entering bad names, it's going to fail. Now I want to give it a good name, so I'm going to have to go to my project and create a file. So let me create a file really quickly. Let's create a file, new text file, and let's just make it in.text. And let's just put some things in it, dog and cat. Okay. So now when I run it and I say in.text, it says, you know, it printed what was in it and it finished. So if I want to handle exceptions, I can wrap it inside a try catch. Now let's do this. Let's expand our try catch to include this code that's at the top. So what I'm going to do is I'm going to temporarily remove the while loop. I don't want to do that check right now. We'll put it back later, but I just want to, for the sake of this example, we'll put it back later. Now, what I'm going to do right now is instead of just including this bunch of code inside the try, I'm going to include the whole code. So I'm going to take my try and I'm going to move it up so that it includes everything. So I'm trying to run this code. Let's indent it inside. Okay. And now let's see if this catch statement, now, you know, everything is inside the try. I'm trying to read a number and do the file, read the file, and all that is inside the try. And let's move the string name up here so that it can be found in the catch. Now let's run this code. And if I try entering a text for the number, it still crashes, even though it's inside the try. Now, if I look here at the exception that's being thrown, it's an input mismatch exception. It is not the file not found exception. And that is why it is not catching it. So when the exception happened, it came to the catch line and it said, oh, do you have a file not found exception? And the answer is no, I have an input mismatch exception. And so it didn't catch it because this catch statement is only catching the file not found exception. So what if I want to catch the input mismatch exception? Well, there are a couple of things you can do. You can come here and say, I'm going to also catch the input mismatch exception. And here what I'm going to do is I'm going to say, give it another name, system.out.println. This is not a valid number. Looks like I have a spelling mistake somewhere. Cannot find symbol input mismatch exception. Do I have a? Let me just copy it. Looks like I need to import it. Let's import it. Import java.util.input mismatch exception. Okay, now the error went away. So this one I have to import. The file not found exception was already imported because we imported java.io.asterisk and that was under it. So if I come here, you'll find the file not found exception. So that's why this one didn't complain. The other exception, I have to import it. And so now if I say 10, it says this is not a valid number, done executing. And I can add the code back for the while loop. Let's add it back for the while loop if I want to, do something. So I can come here and let's set the Boolean failed equal to false, to true. And we can have two of them. So we can have, let's say the number failed. Let's do both of them. And let's have the file failed equal to true. Now, because I have two of them, I'm going to have two while loops. So here I can have while number failed. I am going to keep asking them. So here this should be inside. And when I am done, I will set the failed flag to false, so to indicate that I'm done. So here I'll say number failed equal to false. I succeeded. And then I'll come back and do the same for my my file. Now we changed the name of the variable, so now it's called file failed. Here, let's do this part. And so now let me just fix my parentheses. I need several whiles. Let's see. So here I have my try. I have a while inside my try. So that's good. And then I have my other while that ends here. And then I need to close my try before I can open my catch. So that was my mistake here. I have to close the try, and then all the catch come after. So those are, I'm trying to catch them. So let's shift them, and this one's extra. Okay, so now let's try testing both of them to see if we can succeed and having it ask several times for both of them. So here, if I say 10, it says, oh, it didn't do the while loop. Let's see why. It just said done executing. Oh, the while has to be around the try, sorry. So here, so that means I can't really do it separate. I'll have to just say both of them. So while, so, okay. So okay, so what's happening here is that I'm trying to do a while loop inside, but because the while loop is inside, it's ending right now. It's not ending in the catch. So to do the while loop, I have to make sure the try is inside of the while loop. So I would have to separate them. So let's actually do that. Let's separate them. Well, I don't want to separate them now because I want to show you something else. Let's ignore this and let's continue. What we had here was 2 exceptions. So regardless of what happens, if I say here, if I give it like a bad number, you know, it gives this error message. If I give it a good number and give it a bad name, it gives the other exception. Instead of putting them separate, if I want to do kind of say the same, give the same error message, you can also put them next to each other. So I can say if you find a file not found exception, and this one line is kind of like an or, and here I will say input mismatch exception. Input mismatch exception. I could just say instead of file not found, I will say ran into an error message. So let's change this to and into an error. Okay. And so if you have more than one exception that you want to catch, you can put them there. In that case, I don't need this one because it's already a duplicate. So here, if I run this code now with either of them, it just says ran into an error. Now, it's of course, if you want to, you know, personalize the error message, it's better to catch each one separate, but you can also catch them on the same line this way. Okay. The other thing that you can do is, let's say I don't know all the exceptions that could happen. You know, I just want to, you know, maybe I might write code in the future that catches other exceptions. You can just say catch exception like this. So exception is the parent class of all exception objects, and you can just say catch all exceptions. So here I'm not enumerating every single exception that could happen. I'm just saying catch all exceptions. And so this, regardless of what happens, I will just get the same error message. Now, there's more that we can do. So let's go look at the slides to review what we've done so far before we continue. So here we talked about wrapping code that might run into an exception in a try, and then you say you catch the exceptions that you want. You need to know the exception class over here. The nice thing about exceptions is that they have 2 methods that are useful. One of them is getMessage, and one of them is print stack trace. And let's see an example of them. So here I'm trying to catch an exception. And what I want to do is I want to print the stack trace. Now, printing the stack trace is going to give you the same stack trace that we used to see when we didn't handle the exceptions. Now let's pause for a second and see if this is something that you want to print out to the user. You know, when your computer crashes and it tells you that in, you know, some file in the operating system at line 7282, a problem happened, it doesn't really help you as the user of the, you know, computer or a program. Who does this line help? It helps the programmer, the programmer that wrote the code. So one of the things that you might have seen programs do is create a dump. or they ask you for log files. So sometimes when programs don't run or software doesn't run, what they do is ask you for the log files. The stack trace is something that should probably go to the log file. But going to the exception and getting the message, this is something that you can actually print to the user if you think it is useful. So let's see what both of these, how to use both of them. So here, I caught an exception and I don't know what exception happened. So I just said ran into an error. What I can do is come here and say plus ex dot get message. Now, not everything gives a message. So if I run here and I just say 10, it just says null. So unfortunately, the input mismatch exception doesn't return any message. So it's not really helpful here. But if I run it with the file one is useful. It tells me, it gives me the name of the file and it says the system cannot find the file specified. So getting this message is not always useful with the, built-in Java exceptions. We're going to learn in the next class how to create our own exception classes, and we can write this get message to be meaningful. But this is one thing you can do. The other thing you can do is say ex.print stack trace. Now this is going to print the stack trace to the user. Okay, so this might be useful for debugging. It's not really something that should go to the user, but it might be something that is useful to go to a file. Now the exception class that we've been using is an object. It extends from something that's called throwable. So in Java, there are two types of errors or exceptions that can happen. Exception is the class that handles all the exceptions that we can run. We could kind of try to fix in our code. So if you tried to, something with IO exception, like you tried reading from a file, but the file ended, or you couldn't find the file, or some kind of other exceptions, like the input mismatch exception. Those exceptions we can handle. However, there is something else in Java. There is another class called error, and error is a class that handles also exceptions, but it handles exceptions that are so critical that we really cannot handle in our code. So let's say the JVM crashes. We can't go into the JVM and fix what's in it. The computer ran out of memory. You're trying to write to a file and the computer ran out of memory or ran out of RAM. These are things that you in your code cannot handle. So these are part of the error class. What we are handling are the exception class. So anything that extends from exception, we can handle. And that's why in our code, we can come here and say, I want to handle all exceptions, regardless of what they are. So if there are something that your code can handle, they will extend from exception. So we can write, there might be code that you write and you catch all the exceptions, but it still crashes. And if that happens, it's because Java threw an error, which is something that you cannot really handle in your code. Now, what I just showed you with catching multiple exceptions is called polymorphic references, because all exceptions extend from exception. I was able to handle all the exceptions. I was able to handle the file not found exception and the input mismatch exception in here. So because it has polymorphism, I can actually come here and say if exception instance of file not found exception, I will print a message that says could not find the file. Okay. And let's just put these two lines in there so that you can have them both when I upload the code. Else if ex instance of input match exception, where I can say, personalize the message that I print, not a number. What was the variable called? It was called num, but let's create it up here. 0. then I could say, otherwise, you know, I don't know what kind of exception it is, so I'll just have a generic message that says ran into an error. And I might want to, at that point, print the exception, the message from the exception, and maybe even print the stack trace at that point. So if I can't tell what the error message is, at that point I'll print the stack trace. So here, again, if we run the code, and I give it 10, now it says not a number. Oh, here it crashed. So it told me the number was, like, let's see again, it told me the number was 0. So this is not really, I shouldn't really be printing it because now it's not helpful. But if I run it now with a bad file, the message is different. So because all the exceptions are extending from exception, I can use the concept of polymorphism, where I'm catching all exceptions, and all of them are exceptions, and then I can specialize my message depending on what my exception is, what class it's actually derived from. Okay, so this is what we can do with the exceptions. Now there's another clause that we can put here, which is called the finally clause, and I don't really find it useful because the finally clause will get executed regardless of whether the code runs into an exception or not. So if there's kind of some code that you want to write, whether an exception happened or it didn't happen, you can put it in the finally clause. So it can contain more than one statement, and it will execute whether an exception happens or not. So if I come here after catching my exceptions, I can say finally. Let's just move this one up here. Okay. And so regardless of whether an exception happened or not, it still says done executing. So this code is getting run either way. So it's not really useful because if you put it afterwards, it you know, it works anyways. And then we could put the line like I showed you to catch more than one exception. If you only want to catch a few exceptions, you don't want to handle all exceptions. Now, what if, you know, again, I write code and I didn't handle that exception? It will just fall and it will print the stack trace for us. Exceptions are propagated. So here, if I have a method called do work and it's doing, you know, some work, and one of the things it does, it tries to open a scanner to a file, and that file doesn't exist. If the method runs into an exception here, it's not handling it. So it's throwing IO exception. So remember, before we said if you write a method and the method is not handling the exception, you have to throw IO exception when we're dealing with files. Now, because main is calling this method, it has to wrap this into a try catch. So if you, and we kind of saw this in Java 1. So if I write here, let's create a static void do nothing. And here it tries to create a file. Scanner to it. Because I have that, it tells me that it throws an exception and I have to either catch it or I have to throw it. So I'll have to come here and say throws IO exception. Okay. Now, if I try calling this method in main, here it's not going to do anything because I already have throws IO exception. But if I didn't have throws IO exception, it'll tell me that throws IO exception throws an exception. There's an unreported exception here that must be declared or thrown. So just like when we were calling scanner, you know, scanner forced us to add the throws IO exception line. When you call any other method, you also have to do that. Now, let's say here, you know, let's say do nothing. Let's add another one. Static void do nothing too, and it's not doing anything, but it throws input mismatch exception. So here it's throwing input mismatch exception, and I want to call it in main. Again, let's move this out. I was only complaining about this one. So I guess the IO exception, you're forced to, but this one you're not forced to. We're going to talk about creating our own exceptions. So we're going to be able to actually throw our own exceptions when in the next class. So here, there's a difference between, there's something in Java called checked and unchecked exceptions. So here, we know that this code will not compile when you try to create a file and a scanner, because this is one of the exceptions. The file not found exception is one of the exceptions that Java actually checks. There are other exceptions that it doesn't check, like the input mismatch exception, for example. If you try to go to the scanner and say next int or next float, and the data, there is a mismatch, that is not checked. So that is checked and unchecked in exceptions in Java. So there are ones that it checks and ones that it doesn't check for you. So for this classwork, what you're going to do, you're going to download a student.java file from Blackboard, and you're going to modify it because it has code that will work with HackerRank. And what I want you to do is modify it so that it detects if any line in a file does not contain 3 fields. So you're going to be assuming that there is a file that you're reading and it has 3 fields: the first name, the last name, and the grade of a person. And if any of these lines don't contain these 3 parts, or the grade is not a float, then you will catch those exceptions and print a meaningful message for the user. So do this on your computer, test it, and then when you're done, test it on HackerRank with the code from Blackboard.